It's just after 6 p.m. Eastern Time on Wednesday, July 24th, and you're looking at a live view of Cape Canaveral's Space Launch Complex 40, where a flight-proven Falcon 9 is about to launch a Dragon spacecraft. Liftoff is targeted for 6:24 p.m. Eastern Time or 10:24 p.m. Coordinated Universal Time. My name is Shiva Bharadwaj. I'm a Falcon integration and test engineer here at SpaceX, and it's great to be with you as we cover our 18th commercial resupply mission to the International Space Station for NASA. Now, today's launch window is instantaneous. We'll only launch when the International Space Station is directly overhead Cape Canaveral. If we're delayed, scrub, or abort for any reason, we'll move to our backup launch date, which is currently scheduled for tomorrow, July 25th at 6:01 p.m. Eastern Time. With all systems currently go at both Cape Canaveral and SpaceX Mission Control. And let's take a closer look at today's Falcon 9 and Dragon.
Good afternoon. My name is Michael Andrews, and I work on the supply chain team here at SpaceX. Tonight we'll be delivering more than 5,000 pounds of cargo to the ISS, including critical materials to support dozens of science and research investigations that will occur on board the orbiting laboratory. We'll be going into a little more detail on some of that research later in tonight's webcast. Tonight is going to be SpaceX's 9th launch of 2019, and we'll be launching a flight-proven Dragon spacecraft today. This will be the first time we have flown this particular Dragon capsule for a third mission, as you can see here by the 2 flight-proven decals on the left side of the vehicle. This particular Dragon visited the ISS previously for cargo resupply missions in April 2015 and December 2017. Now, this is a pretty big accomplishment and underscores SpaceX's commitment to reusability and making spaceflight more accessible. You'll also notice another decal on the exterior of Dragon, which SpaceX added to commemorate and celebrate the 50th anniversary of Apollo 11. You may recall NASA's Apollo 11 mission historically landed Neil Armstrong and Buzz Aldrin on the moon in the summer of 1969, making them the first humans to land on the lunar surface. Both Falcon 9 and Dragon were designed with reflight in mind, so the vehicle hardware is built to support multiple missions with minimal refurbishment in between. While this Dragon has flown twice before, the booster we'll be flying today has only flown once before on CRS-18 of this year. And after stage separation, we'll be attempting to bring it back to land at Landing Zone 1 at Cape Canaveral for future missions. And above our first stage is the second stage, which has a single Merlin vacuum or MVAC engine, which ignites after the first stage separates. The second stage is what will carry Dragon to its intended orbit, allowing this spacecraft to eventually rendezvous with the International Space Station. You'll notice today we've painted a gray band across a portion of the second stage that houses our RP-1 fuel. We're gathering data on how sunlight affects the temperature of the fuel remaining in the second stage after we get to orbit. This data will help us further understand how fuel temperatures fluctuate during longer missions like those required in the Air Force. And lastly, one more interesting highlight on today's mission. The outside of the Dragon has been outfitted with 4 ceramic heat shield tiles we are testing for our currently in development Starship vehicle. You might be able to see those black tiles at the bottom of the capsule just above Dragon's trunk. These test-only Starship tiles are being added to this mission to gather data in advance of flying crew on future Starship missions. This is similar to the addition of test tiles to previous CRS missions to gather data in advance of flying people on our Crew Dragon vehicle. It's also worth noting that SpaceX and NASA evaluated each test tile to ensure there is no elevated risk to tonight's CRS mission.
Now, at this point, we're just above T-minus 11 minutes from liftoff, and the SpaceX team is tracking no significant issues with the vehicle. A go, no-go poll was conducted at T-minus 38 minutes, and propellant loading began shortly after at T-minus 35 minutes. Now, at this point, fuel is fully loaded on the second stage, nearly fully loaded on the first stage, and liquid oxygen loading has begun on both the first and second stage, which you can see the condensation from that cool liquid oxygen at the bottom of your screen. We're also loading helium gas into both the stages. Falcon 9 uses helium as a pressurant to backfill the propellant tanks as we consume those propellants by the Merlin 1D engines during ascent. Dragon also began its startup auto sequences at T-minus 35 minutes when it coordinated timing with Falcon 9. It's currently undergoing a series of vehicle health checks with its next major step in about 2 minutes at T-minus 8 when Dragon transitions to its internal battery power. Now, the range at Cape Canaveral is ready to support today's mission. They've issued a series of keep clear and safe zones in the air and sea surface around the launch area. Currently, both the air and sea surface zones are clear for launch. Weather has been a little bit tough today. The weather largely attached anvil clouds high up in the atmosphere have been making the probability of launch today pretty tight. We're going to be monitoring the weather closely up until the last few minutes of launch, and hopefully we'll get a chance to launch today's mission to the International Space Station. So with that, the launch team, Falcon 9, Dragon, and the range reporting green, and hopefully the weather cooperating, we're about T-minus 9 minutes and 30 seconds to liftoff. All systems are go.
Our Dragon spacecraft has been making trips to the space station for 7 years now, and today it's still the only vehicle around that can deliver significant cargo both to and from the orbiting laboratory. Back in 2010, SpaceX became the first private company to send a spacecraft to orbit and return it to Earth. And 2 years later, Dragon became the first privately developed spacecraft to visit the International Space Station. Since then, SpaceX has made a total of 19 trips to the ISS, and we're under contract with NASA for a total of 26 of these cargo resupply missions. Tonight, Dragon will be carrying dozens of research payloads to the space station, including research in the National Laboratory, which is operated by the Center for the Advancement of Science in Space, also known as CASIS. There are more than 25 payloads included on this mission sponsored by the National Lab, the most payloads that CASIS has sent on a SpaceX CRS mission to date. And some of the company's research projects are from organizations you may be familiar with, such as Nickelodeon, Goodyear Tires, and Adidas. The National Lab payloads represent a diverse group of research investigations, all of which are intended to benefit life here on Earth. Now let's take a look at some of the groundbreaking research from CASIS that will be on board tonight's CRS-18 mission.
Investigations sponsored by the International Space Station U.S. National Laboratory are primed for launch on SpaceX's 18th Commercial Resupply Services mission to the orbiting laboratory. When we say that this launch is packed with research, we mean it. This launch has more payloads than we have ever sent on a single mission. Private sector companies, academic researchers, STEM projects, life and physical sciences, all on this mission. So let's get an idea about some of the payloads that are launching on SpaceX CRS-18. The Goodyear Tire and Rubber Company is sending what they hope is the first of many investigations to the ISS National Lab. This initial experiment will evaluate the formation of silica particles in microgravity. Silica is a common material used in consumer tires. However, silica and rubber are materials that don't easily bond. Can the microgravity environment of the space station allow Goodyear to find silica morphologies not possible on Earth? If so, this could lead to improvements in fuel efficiency and other performance factors in consumer tires. The space station is an ever-evolving research platform, and NASA and the ISS National Lab are constantly sponsoring new facilities on the orbiting laboratory to increase the capacity for innovative research. This launch, America's first automated bioprinter for use in space, will make its way to station. Developed by TechShot, this bioprinter will initially seek to print cardiac-like tissue. The printed tissues will remain on station until they are strong enough for the return trip to be analyzed on Earth. While the ability to manufacture human organs is likely many years away, this bioprinter could lead to unique methods of industrial biomedicine and microgravity to develop materials for patient care on Earth. Part of the role of the ISS National Lab is to inspire and educate the next generation. And what better way to do that than by forming fun and exciting collaborations with unique partners? Not many young students understand the term non-Newtonian fluidics in a microgravity environment. However, just about every young student is familiar with Nickelodeon and its iconic slime. So on this mission, Nickelodeon Slime in Space will make its way to station for a variety of demonstrations to educate students on the basic concepts of fluid flow and microgravity compared with normal gravity conditions on Earth. So there you have it. Advanced materials, industrial biomedicine, education payloads, new facilities, and repeat flight partners. This mission represents the demand that continues to build as more researchers and companies recognize the unique potential for sustained R&D in microgravity. To learn more about all ISS National Lab sponsored payloads on this mission and how to become part of the space station research community, visit issnationallab.org.
You've learned about just a small sample of the dozens of research experiments that Dragon will take up to the space station. You can follow @space_station on Twitter for more information on the exciting microgravity research happening on the station. And now there's one other piece of cargo on board today to mention. It's a new International Docking Adapter, or IDA-3. This piece of hardware connects spacecraft to the International Space Station. IDA-3 attaches to the Harmony node of the ISS and can accommodate commercial crew program vehicle dockings, including the first spacecraft to launch astronauts from U.S. soil since the Space Shuttle. IDA-3 is identical to the International Docking Adapter 2, or IDA-2, we sent on CRS-9 in the summer of 2016. IDA-2 was actually used by SpaceX during our first uncrewed flight test, Demo 1, in March of this year. And later this summer, 2 Expedition 60 crew members will perform a spacewalk to permanently install that IDA-3.
Now we're just about T-minus 4 minutes and 30 seconds, continuing towards our 6:24 p.m. Eastern launch to the International Space Station. At this point, I've gotten an update that the weather is currently no-go. However, we're going to continue to try to push until the last few seconds of the launch, hoping we'll get that opportunity to send Dragon to the space station. In these last couple of minutes, Falcon 9 is performing a series of final health checks on its primary communications, avionics, and propulsion systems as it prepares for flight. And as we mentioned earlier, we're currently loading fuel and liquid oxygen into the propellant tanks. Right now, fuel is fully loaded on both the first and second stage, and liquid oxygen is nearly fully loaded on both the first and second stage, with that finishing at T-minus 2 minutes. Right about now, we're also performing engine chill-in on the M1D engines. That's where we inject a small amount of super chilled liquid oxygen to prepare those engines for full propellant flow during flight. You may hear the announcement that the engines are sufficiently chilled in later on in the countdown. Earlier as well, we performed thrust vector control actuations. Sometimes you'll hear those referred to as the engine wiggle test, where we'll wiggle the nozzle slightly to make sure it'll go for flight. The first stage engines perform a similar wiggle in just a few seconds before engine ignition. Coming up at T-minus 1, Falcon 9 will transition into startup, at which point it will autonomously guide the rocket through the rest of the countdown. The launch director will issue a go for launch at T-minus 45 seconds. A few seconds before liftoff, the engines are ignited. Then at T-minus 0, the rocket is released from the hold-down clamps, and the transporter erector, that truss structure on the left side of the vehicle, will pull away from the rocket, clearing the way for Falcon 9 to ascend. Dragon is performing a similar series of health checkouts to prepare for its 2-day journey and rendezvous with the International Space Station. At this point, the range still remains go for launch. Weather is still no-go for launch, but we're going to continue to push through until the last few seconds. So with that, let's listen in to the countdown nets for terminal count.
Falcon 9 startup.
Dragon is in startup.
Hold on countdown 1. Launch board's running.
Please proceed to non-crewed scrub, post-static fire procedures.
So as you just heard on the launch nets, we've had a hold for weather Now, the weather has been tough. There was a tropical depression in the area that's just made tough weather for today's launch. And unfortunately, today's mission was an instantaneous window, so that means that we'll be going to tomorrow's backup window for the launch. Now, the great thing is the vehicle is healthy, both Falcon 9 and Dragon, and so that gives us a great opportunity for launch tomorrow, July 25th at 6:01 p.m. Eastern Time, or 10:01 p.m. Universal Coordinated Time. So we'll see you back tomorrow for live coverage of our launch to the International Space Station.